Hey guys, my name is Nitendra. I'm 15 years old and today I'm going to explain about benzene. Yeah, today we're going to talk about benzene. Benzene is essentially cyclohexene. 1,3,5 cyclohexene. That's where the double bonds are at the first carbon, third carbon and fifth carbon. But it's hard to pinpoint the locations of the double bonds because they are resonating, jumping from one place to another. So benzene is just like a hexagon, your regular hexagon, except there's double bonds on the sides. Any three sides. Now not consecutive sides, they are in alternate sides. This is called conjugation. This is also another effect in organic chemistry. Well, I'm talking to you about organic chemistry and benzene is a small part of it. It's just the tip of the iceberg. The organic chemistry is a massive topic. We'll focus on benzene for now. So benzene is a ring. As I told you, it looks like a hexagon and it has double bonds. And there are also other names of benzene, like if you add a methyl group. What do I mean by methyl group? You know methane, right? Carbon and 4 hydrogens. Remove a hydrogen and add it to the benzene ring at anywhere, any place you want. Then it becomes toluene. Similarly, if you add alcohol group OH, one oxygen atom and a hydrogen atom, if you add that to benzene, you get phenol, not phenyl, phenol. Phenyl is C6H5. It's essentially benzene, but with one hydrogen removed. It's like a substituent that can be added to another carbon. But this is phenol. Phenol is benzene with an alcohol. And next is aniline. Aniline is benzene with a nitrogen group, NH2 to be precise. Two hydrogen atoms and this benzene ring is attached to the nitrogen. So we call it aniline. And next after aniline comes anisole. What is anisole? It's you know I mentioned that alkyl group, right? Methyl group, one carbon, three hydrogens. Yes, add an oxygen instead of the benzene ring, and to that oxygen add the benzene ring. So you essentially get benzene ring here, oxygen atom, and then CH3. That is the methyl group. So this is called anisole. And next there is xylene. What is xylene? I told you if you add one CH3 to the benzene ring, you will get toluene. If you add two, you get xylene. Now you might be thinking, since benzene is a hexagon, we can add it here, here, or here, 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 here. We can add it adjacent or like this or completely opposite to each other. So what do you have to call them then? Well, if they are adjacent, this is called the ortho position. So if this is the primary, well, not primary, if this is one CH3 group and you take the secondary CH3 group here, you can call it ortho, and then this position is called meta. And when they are totally parallel to each other, well, as in parallel I mean on the straight line and opposite to each other facing away, you can call them para. And next comes mesetyl. What is mesetyl? Well, if you take a benzene ring and then as I mentioned, you have the meta positions, right? Take a CH3 group like this and then like this. It's essentially like a triangle. So if you do that, you will get mesitylene, sorry. It is a substituent of benzene, not a substituent but derivative. Fun fact about benzene, it's an aromatic compound. It gives off smell. Why is it aromatic? Because all the carbon atoms are in the same plane. As we know, sp2 hybridized carbon atoms are in the same plane. What are sp2 hybridized carbon atoms? Well, that's a long story, but you can consider them as this. Just carbon atoms with a double bond between each other. As I said, benzene has 3 double bonds and they are resonating. They are constantly jumping from one place to another. That makes the benzene ring more stable. So, as I said, sp2 hybridized carbon atoms are planar. What do I mean by planar? Well, if you imagine this as the double bond, here are carbon atoms, and then there's one hydrogen atom here, another here, another here, another here. They are all lying in the same plane but not in a straight line. That's called linear. When does this linearity occur? Well, if you take an sp hybridized carbon atom, well, I told you sp2 has double bonds, right? Add another bond to that. You get a triple bond like this. So the two carbons have a triple bond between them, and then the hydrogens are just straight facing away from each other. Then you get a linear carbon compound, which can be called as a linear compound. As I told you, it's linear because it has a triple bond. And then there is the single bonded carbon, the tetrahedral carbon, sp3 hybridized. This is basically a pyramid. One here, one here, one here, and the other facing towards you. So we are talking about sp2 here. Forget the other two, sp3 and sp2. Not forget, just leave them out for a while. Well, now we're talking about sp2, right? They are all in the same plane. This is an essential condition for aromaticity. And then also, As I told you from the very beginning, I've been yapping about it for a lot of time. Benzene has three double bonds. What do those three double bonds mean? It has six resonating electrons essentially. Well, 6 can be represented as a multiple of 4n plus 2. If you put the value of n as 1, you get 6. So it follows Huckel's rule. This following Huckel's rule and being planar makes the benzene aromatic. Well, aromaticity has its own benefits. If the compound is aromatic, it is more stable. And as we all know, every compound forms bonds to become more stable and just lower its energy level from the top to the bottom. It wants to come down to top to bottom because that's where it's stable. And then where was I? Yes, the benzene is aromatic. What is aromatic? You can smell it. Aroma, it gives off a unique flavor. It's usually sweet, but let's get to the point. I was talking about some substituents, derivatives of benzene, right? Yeah, benzenoic acid. What is benzoic acid? You take carboxylic acid. Do you know vinegar? Vinegar is used in fast food stalls mostly, but it's actually a kind of organic compound. You're using a functional group called carboxylic acid. Now, if you attach this carboxylic acid to the benzene ring, which smells flavorful, then it will become benzoic acid. This is also a derivative of benzene. And benzene, well, benzene doesn't have many uses, but it is actually useful for, it is the base of many aromatic compounds. Now, I will tell you a bit more about aromatic compounds. They follow Huckel's rule, they are planar. And what is Huckel's rule? Huckel's rule is just 4n plus 2. You need to express the double bonds. One double bond counts as 2 electrons. Now, if there are 2 double bonds, that means there are 4 electrons, right? 4 is a multiple of 4n. You place 1, you get 4. So, it is anti-aromatic, not aromatic. To be aromatic, it has to follow Huckel's rule, which is just to be a multiple of 4n plus 2. And I told you about the derivatives of benzene, like aniline, anisole, toluene, xylene, mesitylene, and then now benzenoic acid. So I hope you learned a lot about benzene through this video. Bye guys, and let's continue this series about organic chemistry more in the next video. Bye.